Hello, and welcome back to Bite-Sized Neo4j for Data Scientists. This is part 12 in our series, and today we're going to talk about how to create an in-memory graph with native projections. This is a function of the Graph Data Science Library, and in part 10 we looked at one way to create these graphs with cipher projections, but today we're going to talk about native projections, which can be much faster. My name is Claire Sullivan, and I'm a data science advocate at Neo4j. Here's how to reach me on the internet. Before we begin, I just want to remind you of the links that we have for this course. The first is how to create a free sandbox instance. The second is the playlist for the course where you can watch all of the previous videos. And the last is the repository for the course where you will find all of the code that you'll see today. Okay, so first things first, I've created a Game of Thrones, the Graph Data Science free instance on Sandbox. And if you recall, this has the Game of Thrones graph populated into it. Now what we're going to do is we're going to create these in-memory graphs, which are the basis for all of the things that we can do with the Graph Data Science Library. And here's how we're going to do it. Okay, call GDS graph create, and we're going to give our graph a name. This one's called interactions, and we have what's called a node projection and then a relationship projection. So I pick which nodes that I would like in this graph, and I pick which relationships I would like, and it's that simple. Okay, so we can see that I created a graph. It's got 2,166 nodes and 3,907 relationships. That's great. Okay, that was pretty simple. Now, we can make these more complicated depending on the needs for your calculations. For example, here's how we would create an undirected graph. What you'll find is that the GDS library likes undirected graphs more than it likes directed graphs. So in this case, I have a map which basically just looks like a dictionary, for my relationships. I still have my person nodes, but now I'm going to pick my interacts relationships, but then I've got these properties that I'm setting in this next dictionary. For instance, I have a property called orientation that we're setting as undirected. So we'll give that a run. And what we see here now is that I have a relationship count that's twice what it was before, because basically what's happening here is that we can go back and forth along the same relationship. All right, cool. Let's look at a different type of property that we could use. For example, my relationships might be weighted based on, say, the number of interactions two people have within my graph. So again, I have that same format where I'm creating a large dict of my interacts relationships, but now I'm setting a property called weight. And what you'll find as you run different GDS algorithms is that you can specify the name of your weight property so long as it's within your in-memory graph. Okay, so that's cool. Now, what if we want to have multiple node types within our graph? Well, that's very doable. Oh, I forgot to run that one. Okay, now here's multiple node types. You'll see that I replaced my node projection with a list. So in this case, I'm specifying that I'm creating a graph between person nodes and house nodes, and it's going to be using the belongs to relationship. Okay, so that's cool. People belong to houses. Now, how do I know that that actually ran correctly? Well, I'm going to run this particular cipher query. So I'm just looking at which people belong to which house, and I'm just going to return the count of the number of relationships. And what you see is that I have 2,220 relationships here, which matches what I had when we created the in-memory graph. So that's good. That's a nice gut check. Okay, let's do a complicated one. I'm even going to call it fancy graph. Okay, here's fancy graph. So I am going to specify my node projections as lists between people and houses. I can have people interacting with other people, in which case I'm going to specify that I want that orientation to be undirected. I want my properties that are brought in to be the weight of that interaction. And then I'm also going to bring in my belongs to relationships here. And orientation natural just means that it's like a directed graph, whatever it's actually stored in the database as. Okay, so I can give that a run, and I've generated an in-memory graph with both of those nodes and both of those relationship types. Okay, now, just really quick, we can see what graphs we have in memory calling GDS graph list. Okay, and I have several of them, all the ones that we just created. And then, of course, it's a good idea when you're all said and done to clean up after yourself. So I can drop my in-memory graphs one at a time based on their name. Okay, that's all there is to it. So thank you for tuning in again. If you would like to see any subjects in future videos, please reach out to me on Twitter, and have a great weekend. Thanks.